So in this example, we're going to look at the relationship between electric field, electric potential, electric force, and electric potential energy. And so you'll notice I've drawn four circles here. Top left one has an F in it, representing electric force. Top right is E for electric field. Bottom left is U for electric potential energy. Bottom right is V for electric potential. And so what we're going to do is draw out every relationship between these four and see how similar they are. So starting at the top, we notice that if we have a point charge, the force on the point charge is just Q times E, where E is the electric field. And similarly at the bottom, if we have a point charge, the change in potential energy is equal to Q times the change in voltage. On the right side, we notice that the electric field is given by a negative gradient of the potential, and the change in potential is given by a negative path integral of the electric field over some path. And similarly on the left, the force is given by a negative gradient of potential energy, and the electric potential energy is given by a negative path integral of the force over some path. So, suppose we actually want to put this to use. Let's start off with the force due to one point charge on another. So I have K, Q1, Q2 divided by R squared, R hat. And let's pretend I want to take this expression and analyze Q1, the properties of Q1. Well, first off, I know that force is equal to Q times E. So the electric field due to Q1 is just going to be the force expression divided by Q2, or it's going to be K Q1 over R squared, R hat. If I want to turn that into a potential, I can take a path integral over the electric field, and in this case dl is going to be dr, and I get V is equal to K Q1 divided by R. If I want to take that and figure out the potential energy of a charge Q2 within the potential of Q1, I can multiply it by Q, and I get K Q1 Q2 divided by R. And so you can see that we can go around this square and figure out the relationships between the force, the field, the potential, and the potential energy. And so, a couple of parting thoughts. All of these concepts are intimately related. And so in a problem, if we ever give you one of the four, using the relationships that you saw in the previous slides, you can go to any of the other ones. And we see that these relationships extend outside the realm of electricity. And what I mean by that is, in this class at least, we did not specifically talk about how force and electric potential energy are related. That was something we covered in mechanics. However, we see that it shows up in this little square that we drew. So remember, electricity is not its own little separate world. It's intimately connected to everything that we learn in physics before now and everything we're going to learn after.